Hi, welcome to the part 7 of this video series. In this video, we are going to cover the Azure TP 900 data fundamentals, important exam questions. Now, please focus on the explanations provided in this video series. That will help you clarify your concepts. For questions 1 to 60, please refer parts 1 to 6 of this video series. Please subscribe to my channel. Now, let's jump into the questions. So this question says that by default each Azure SQL database is protected by which one of these? If we see these, each SQL database is protected by a firewall. Now which firewall? Is it Azure firewall or server level firewall? Now each database is protected by a server level firewall. And the server level firewall doesn't work for SQL managed instance, but in this case we are asking, the question is asking for Azure SQL database, it then server level firewall will work. You can connect to single database or elastic pools, and you can also connect from other Azure resources as well as from on-premises. Now front door is example of using edge locations for web page deployment that will use the edge locations and display the web pages a lot faster. It helps in boosting the performance of displaying the web pages. In this case, it is irrelevant because this topic talks about Azure SQL database. Now let's go to the option NSG. What is NSG used for? Now each Azure resource has an NSG if it is a virtual network. Now this doesn't apply much to the Azure SQL database. It mostly works on VMs, which is the virtual machine on which you can install databases, and it can also work for SD inside clusters. Primarily it is used to filter the inbound and the outbound traffic. So if, for example, if you don't want your database to be accessible from the internet, and if your database is installed on a VM, then you can use NSG to block those IPs. In this case, SQL database is always protected by a firewall, which is at a server level, not at the Azure firewall. Hence, the second option is the right answer. Let's move to the next question. Now, this is a really easy one, a no-brainer, and I got this question in the exam, exactly the same question. Please read this. Now the question says the quantity for the product 1 is 100 and you want to update it to 270. So which statements you will use? It's pretty obvious, you will use update. Now insert is used to insert the data, merge is used to merge the datasets, and create is a DDL. It is used to create a table or views or indexes. Hence option C would be the right answer. Let's move to the next question. This is again a very simple question, and this also came in the exam, exactly the same question. And the answer for this is a view, because view doesn't exist in physically, it is existing virtually. It's a virtual table which is sitting on top of a table, and in order to create a view you use a statement like create view name as select star from some of the tables with a where clause, etc. So a view is always based on a query, and that query is based on the tables. This option is correct. We lock this, and let's move to the next question. Before we move to the next question, let me explain what is an index. An index is used to increase the performance of the queries in the database. So you use a create index statement, but it is not a virtual table. Let's look at the stored procedure. Stored procedure is a set of code which you can use for data manipulation, etc., but it is not a virtual table. Let's look at this question. If you are already from a data background, then this question is a no-brainer for you. So relational databases, they use keys to enforce relationships. There is always a primary key and a foreign key, and if it is a highly normalized database, we always use primary key and foreign key. That defines the integrity definitions, and that is also called integrity relationships. So this is very important, defining the keys, and this will help you enforce the relationships between different tables. Columns are just set of columns in a table, and it itself cannot define the relationships. You have to use some keys to define the relationships, usually between these two, some of the two tables. If you're defining the relationship, we do a 1:1 or 1:many, etc. That means for each record, each primary key, there can be multiple records in the other table, or in some cases for each record in primary table there can be only one record in the secondary table. That is called 1:1 relationship. Now what is the use of partitions? Partitions is used to store datasets of a similar type in one partition. That way it is easy to access the data and the queries are faster. So we'll lock this answer, keys, and we'll move forward. Let's look at this question. So the question is asking, when should a relational database be used? Let's scan the options. The first option, that's a dynamic schema is required. This is a property of a NoSQL database because the schema is not defined. It has a dynamic schema. So this is not a property of a relational database, and so we'll skip this. The second option, data will be stored as key value pairs. This is a property of a document DB, something like Cassandra or MongoDB. Not relevant for a relational database. We'll skip this. Let's look at the third option, storing large images and videos. This is a property of object store and not a relational database. So this is something like Azure blob storage. You should use this, but you should not use a relational database for this purpose. Hence we have striked out all first three options. So the fourth option is the correct one. What do we mean by strong consistency guarantees? It means that if I insert a record now, and if you are accessing this record after some time, it should be exactly the same. There should be no discrepancy in the writes and the reads. NoSQL databases and document DB databases are not providing you strong consistencies. There is something called ACID compliance. Please have a read. All the relational databases are designed so that they are perfectly ACID compliant. So we will lock this answer and proceed forward. Please read this question carefully. This is a no-brainer if you are already coming from a database background. It's pretty easy for you to answer. The correct answer for this is a cluster index. What is a cluster index? See, an index is used always to increase the performance of your queries. Now, file table is used to store file stream data. It has a fixed schema. It can also store a file directory information. It is a property of SQL Server. So I already showed you. You can do a Google and have a read for the file table. A stored procedure is a set of code which is used for data manipulation and processing or ETL. Something, before ETL tools were in place like Informatica, DataStage, etc. We used to write stored procedures, and using stored procedures we used to do a lot of data manipulation, extraction, transformation, and loading. But that is irrelevant in this case. In this case, the cluster index is the right answer. Let's move to the next question. In this case, the question is asking for MBB engine of a Synapse Analytics. In this case, see, whenever you think about Synapse Analytics, it's always compute nodes. It is using compute nodes, and that's the reason it can perform high volume transactions and massively parallel processing. And it is always based on compute nodes architecture, node-based architecture, and that's why it can handle such huge volumes of data. So this is the right option because the distribution is done across the compute nodes. It is not done across the control nodes. There is nothing called the control nodes, and then there is no redirection of the client connections across the compute of the control nodes. It distributes the processing across the compute nodes. Always remember that any high volume of data processing is always done through the compute nodes because it enables horizontal scaling. Even SD inside clusters and big data clusters, they always rely on compute nodes or node-based architectures because it provides them vertical scaling options to process more data. Horizontal scaling options. It provides horizontal scaling options. By default, vertical scaling options are already there. Any database, like for example SQL database and etc., they have vertical scaling options, but horizontal scaling options is something which will help you process humongous volumes of data, something like a big data, etc. That's why in the big data architecture you will always see node based architecture, and the compute nodes are increased if more processing power is required. Now this brings us to the end of this video. Please subscribe to my channel and like my videos. If you have any comments or if you think this set of video series is helping, then please drop in your comments. It really helps me motivate myself. I'll see you in the next video. Till then, bye.